All right, so this is chapter 8, section 2. We're going to talk about operations with matrices. We talk about equivalent matrices. They have the same number of rows, same number of columns. If they do not have the same rows, same columns, I cannot add or subtract matrices or solve for x and y in a particular element. So specifically, we're looking at these two. Yes, they're both 2 by 2s. I have 2 rows, 2 columns, 2 rows, 2 columns. Therefore, I can solve for y here. So I'm going to say y plus 1 equals 5. Then y equals 4. So I just solved for y because the positions were equivalent. I could do the same thing with x. X equals 1. I can do the same thing with z. Z equals 3. And then here clearly we can see that 6 is in the same position in both matrices. Alright, so here's another example. The instructions say find the values of x and y that make the matrices. Okay, so what I want to do here is I know that this element is going to be equal to this element. So I'm going to write a statement of equality that 3 equals y minus 2. Add 2 to both sides, we get y equals 5. So we just solved for y. I'm going to do the same thing with x. Here, the element, I'm going to set them equal to each other. So x plus 1 equals 8, x equals 7. So we just solved for x and y. Again, I'm going to reiterate, when you're adding or subtracting two matrices, so let's say matrix A and matrix B, two independent matrices, you can only do that if the order is the same, or the dimensions, whatever you want to refer. So specifically, let's take a look at this example. Let's start with A. They are both 2 by 2 matrices, 2 rows, 2 columns, 2 rows, 2 columns. Therefore, we can add them. I'm going to go ahead and I'm going to add the elements together. So similar positions being combined. So first row, first column, first row, first column, I'm going to add them together. 2 plus 5 is 3 plus negative 1 is negative 4 plus 7 is, and 6 plus 0 is, and that would be my resultant matrix, 2 by 2. Okay, here's B. They are both 2 by 2 matrices, so I know I can combine them, and this time we're subtracting. My resultant matrix is also going to be a 2 by 2, so I'm doing, here if it helps you, do plus, and then switch your sign so that way you remember that you're really adding a negative or adding a positive, okay? So negative 6 plus negative 7 is negative 13. Negative 3 plus negative 10, negative 13. 10 plus 3 is 13, and 4 plus negative 8 is negative 4. All right, let's take a look at these two matrices. If you look at the first one, this is a 2 by 3. And if we look at the second one, this is a 2 by 2. Because the dimensions, oh, I wrote 2 by 3, I meant 2 by 2. Because the dimensions are not the same, I cannot add them or subtract them. So we would say not possible because of the different dimensions. All right, ready for D? All right, so here what we're going to do is we're going to combine. They're all 2 by 2 matrices. I'm going to combine the elements to each position, and I'm going to work out the order in which the elements are presented to me. So my first term, I have 2 plus 5 is 7, minus 3 is 4, and then I have 3 minus 1 is 2, minus 1 is 1. And then in my next position, I have negative 4 plus 7 is 3, minus negative 2 is 5. And then I have 6 plus 0, 6 minus 7 is negative 1. Okay. When we have scalars, we're going to think about what we did with the vector, similar concept, okay? We're going to multiply each entry by the scalar multiple in that matrix. So let's say I have half of the following matrix, 2, 4, 6, 8. So everything in that matrix is basically being reduced in half. So that's going to become 1, 2, 3, 4. All right, so let's go ahead and carry out that scalar multiple for this example. Here we're multiplying each term by 3. So we have 3 times 2 is 6. 3 times 4 is 12. 3 times negative 5 is negative 15. And then 3 times 7 is 21. So here's my new matrix multiplied by a factor of 3. So sometimes we have multiple operations, and that's typical of some matrices. So let's take a look at our first one here. We're going to multiply a by a scalar of 2, so that's what this one wants us to do. So 3 times 2 is 6. 2 times negative 1 is negative 2. 2 times 2 is 4. 2 times 7 is 14. So that would be this first one. Then if we look at B, it wants us to take 3 times B and then add that to A. So I'm actually going to go ahead and do that. So let's start with 3B. So 3 times 5 is 15. 3 times 10 is 30. 3 times negative 2 is negative 6. And then 3 times negative 1 is negative 3. And I want to add that to A. So I'm going to duplicate A over here. And once I have that, then I can conduct the operation that I have here. 15 plus 3 is 18. 30 plus negative 1 is 29. Negative 6 plus 2 is negative 4. And negative 3 plus 7 is 4. Okay. So here's B, and we're going to do minus 3 times A. So I'm going to take 3 times what I have for A. So let's just put that next to here. So 3 times 3 is 9. 3 times negative 1, negative 3. 3 times 2 is 6. 3 times 7 is 21. So now I'm going to take the difference in these matrices. So 5 minus 9 is negative 4. 10 minus negative 3 is 13. And negative 2 minus 6 is negative 8. And negative 1 minus 21 is negative 22. All right, so let's switch it up. Let's talk about matrix multiplication. This time it's different. This time it's not about the order being the same in both matrices. It's about the dimensions in the columns for the first matrix matching the number of rows in the second matrix that I'm multiplying. So here it just so happens that the order does match, but it doesn't have to, as long as, again, this is a 2 by 2. This is a 2 by 2. Remember, it's rows times columns. So if the columns matches the rows in the second matrix, then you're able to multiply. That's the only criteria that you need for multiplying matrices. If that's the case, then the outer dimensions is going to be the resulting matrix. So your resultant matrix is going to be a 2 by 2. When we multiply matrices, this is how we do it. What we do is we take the first row and we're going to multiply it to column 1. The elements that line up, specifically these two and these two, are going to be multiplied, and those elements are going to be added together to equal one element. Once we're done with that, then I move on to first row, second column to get this term. Again, we're going to line up A and F, then B and H, and we're going to add them together. Once we're done with row 1, we work our way down the rows. So now I'm on row 2, and then we go to column 1, and that's where this term comes into play. Then we move down the column to column 2, and we get this element. Let me show you an example so that way you start getting what the pattern is. All right, recapping. So what this is basically saying, that your inner dimensions, again, when they match, then you're allowed to multiply them. Your outer dimensions, that's going to be the resultant matrix. So for example, let's take a look down here. This is a 1 by 3, and this is a 3 by 1. That's what it's writing up here. Because the inner dimensions match, you're going to end up with a 1 by 1, and you end up with just the number 32. The same thing happens here. You have a 3 by 1 and then a 1 by 3. So you're going to end up with a 3 by 3 matrix, which you do here. All right, remember the properties that you learned in previous math courses: associative, commutative, the zero property, the multiplication property, all those fun properties. Well, the ones that apply to matrices are the following: associative, distributive, multiplication, and associative property of scalar multiplication. That's it. Notice that the commutative property is not part of this list. Remember, the commutative property states that the order in which we multiply does not matter. 1 times 2 is the same as 2 times 1. That does not extend to matrices. Matrices, the order matters. So matrix A times matrix B is not the same as matrix B times matrix A. So do not do the commutative of the matrices. It won't work. You will end up with something funny. All right, so let's recap. How do we multiply? Let's go over it. So we want to find the product. So what I'm going to do is I'm going to write the dimensions down first. The matrix on the left, let's call it matrix A. It has 1 row and it has 3 columns. The matrix on the right, let's call it matrix B, has 3 rows and 1 column. Because the inner dimensions match 3 and 3, that means you can multiply them, right? That's what I taught you. So I look at the outer dimensions to determine what is the resultant matrix. It's going to be a 1 by 1. So your resultant matrix is going to be a 1 by 1, meaning one number. And that makes sense because we're going to take this first row and combine it to this first column. I don't have to move any further when I do that. When I do that, it's going to be the first elements match up. Then you add it to the second set of elements through multiplication, and then to the third set of elements. So now we can simplify that. -2 times -4 is 8, 1 times 1 is 1, 3 times 2 is 6, 8 plus 1 is 9, plus 6 is 15. So I end up with one number. And I knew I was going to end up with that because of this. So you can use this idea to check to make sure that you did it correctly. All right, let's find the product of this matrix. I want to go ahead again. I want to determine the order first, the dimensions of each matrix. This is a 3 by 1, and this one on the far right is a 1 by 3. The inner dimensions match. Therefore, my outer dimensions is going to be the resulting dimensions of my new matrix. So it's going to be a 3 by 3. So this is a good example to determine what your new values will be, so that way you really get the idea of how to multiply these. So I always start in the first row and I go to the first column. Those are the elements that I'm combining through multiplication and addition. But because there's only one element in each, it makes it very easy. I only have to multiply them. So here it's going to be -4 times -2. That's element 1 in my new matrix. The next thing I want to do is go to first row, second column. That's going to be first row, second column of the new matrix. So -4 times 1. And I'm done with row 1, column 2. So now I go to row 1, column 3. Okay, so row 1, column 3 would be -4 times 3. God bless you. And now we're done with the row 1 and all the columns. So now I move my way to row 2, column 1. So that's 1 times -2. I'm done with column 2, so now I go column 1, so now I go to column 2. That's 1 times 1. I'm done with column 2, so now I go to column 3 of the next matrix. So that's 1 times 3. We're done with row 2 and column 3, so now I work my way down to row 3, column 1. So that's 2 times -2. So notice the pattern. You kind of work your way through all the elements and you match them up. So 2 times 1. And now we're going to column 3. So that's 2 times 3. So now that I have this new matrix, I'm going to go ahead and simplify. -4 times -2 is 8. -4 times 1 is -4. -4 times 3 is -12. 1 times -2, -2. 1 times 1, 3 times 1, 2 times -2, 2 times 1, and 2 times 3. Notice that we ended up with our 3 by 3 matrix, so we know that we did it right. All right, let's find the product here. So let's start by writing down our dimensions. So this is a 4 by 2, and this is a 2 by 2. The inner dimensions match, so our resultant matrix is going to be the outer dimensions. So it's a 4 by 2 as well. It's going to look like this one, okay? So my matrix should end up looking like this. If it doesn't, I know I did something wrong. So I'm going to work my ways through the rows and the columns, so let's start that process. First row, first column. So now you're going to match up element 1 with element 1 in each row and each column. So negative 1 times 4, and then plus element 2 of row 2, element 2 of column 1. So that's going to be 2 times negative 2. Now that we're done with column 1, we go to column 2. So that's going to be negative 1 times 0 plus 2 times negative 3. Now we're done with row 1 and all the columns. So we work our way to row 2, column 1. So that's 0 times 4 plus 1 times negative 2. So again, the first element of the row matches up with the first element of the column plus second element in that row, second element in that column through multiplication. We're done with column 1, so now we go to column 2. So that's 0 times 0 plus 1 times negative 3. We're done with row 2, so now we can go to row 3. So that's going to be 3 times 4 plus negative 1 times negative 2. Next column, 3 times 0 plus negative 1 times negative 3. And now our final row, row 4, to column 1, 1 times 4 plus 2 times negative 2. And then last column with that same row, 1 times 0 plus 2 times negative 3. All right, so let's simplify what we have. Negative 1 times 4 is negative 4 plus negative 4 in this first term. That's going to be negative 8. My next term I know is 0, and I have 2 times negative 3, so that's negative 6. My next term, 0 times 4, 0, plus 1 times negative 2, negative 2, 0 times 0, 0, plus 1 times negative 3, negative 3. 3 times 4 is 12, and then this is plus 2, that's going to give me 14. This is 0 plus 3, so that's 3. Then this is 4 plus negative 4, that gives me 0, and then this is 0 plus negative 6.